So essentially, what I will try and do is present for about an hour and 10 minutes maximum, a little bit of theory behind blockchain and what we're trying to do, combining it with architecture and other digital tools in architecture. And then we'll go slowly through a smart contract, essentially the one on non-fungible tokens. And I will explain how that can be used for a circular economy of buildings. If we have the time, we'll also try and connect Blender with the smart contract. If we don't, I will still give you the code and instructions on how you can do it. If one of you is interested to kind of try it, on your own later, or you want to try other different things that you're going to learn through the workshop, feel free to kind of contact me and ask for help and so on and so forth.
Yeah, it sounds great.
So I'll just say a few things about myself. I'm an architect. I am also a researcher and a teacher in Robert Gordon University in Scotland. And my main expertise is into digital design with a specific focus mostly on generative systems. So essentially, I build tools for architects to be able to work with design. Let me try and open my files and then I'll try share.
Yeah, can you share the screen? Yeah, do you have a permission?
Yeah, give me a second.
Okay, perfect. We can see your screen.
Okay, it's probably going to change now. Can you still see my screen?
Yeah, but it's not just one slide. We can see like current slide and next slide also.
Okay, what about now?
Still the same.
Okay.
We're seeing the presenter view, I think.
Yeah, so do you see a diagram with lots of nodes?
Yeah, now it's good.
Okay, perfect. So we're gonna start essentially by discussing what a blockchain is. And essentially, a blockchain is a network of computers, which each one of them actually holds a whole copy of the ledger, the information that you want to store, essentially. And that is what makes it resilient, right? So if you lose one node on the network, that is not a complete loss in the sense that you're able to retrieve the information from another node, essentially. It started as a technology in about 2009 by a person or groups of people called Satoshi Nakamoto, who at the moment we still don't know who they are, where they described essentially a computer network like this set up so that they would solve the double spending problem. And I'll kind of try to explain what that means, right? If you have a set of, I'll explain it with files rather than with money. If you have a set of files on your computer, right? So say 100 songs, and you send a copy of a song to me, you just created a new copy and you did not kind of lost your copy, right? So on computer networks and on peer-to-peer networks, we used to have this kind of sharing culture, which obviously, if you try this with money, it will not work, right? If you send me €1 or £1, right, on your side, we need to deduct a pound or a euro. So Satoshi essentially was able to create a network where each one of the participants is holding a copy of all accounts. So if you need to compare it with how banks work, right? If I go and buy a coffee and I use my card to do it, right? Essentially, the machine at the coffee shop will ask the bank, does Theo have the money to buy this, right? And the bank will say yes, and then they will deduct the amount from my bank account. And at that moment, you're trusting first of all, you're trusting the bank, right? I'm trusting the bank as well, and we're all trusting this as an institution, as a third-party system that kind of keeps track on the ledger of how money everyone has. If you take it from the point of view of cash, right? If I have €1 and I buy coffee with this, right? I transfer the physical token to someone else. So what Satoshi did is he essentially said we can, do away with the banks just by everybody holding a copy of all transactions on the system. But this is where you start to have a problem in terms of who says the truth and who doesn't, right? Because I could be participating in the network and I could be judging my account with millions of euros, right? So going in and where it says I have only €5 to basically say I have 5 million, right? So how do you keep participants in the network honest, right? That's the first question. And also, how do you synchronize between the nodes? So to keep participants honest, they came up with the idea of incentives and the idea of mining new currency in the system. So some of the nodes are in a competition to mine the next block of information, the next block of transactions, and who solves first a really difficult mathematical problem gets rewarded with more currencies. And this is how we call what we call essentially cryptocurrency mining in blockchain context. And from that point of view, if you set it up algorithmically in a certain kind of way, you get essentially a very good trustworthy system, right? That you can trust, and you can trust that everybody on the network says the truth. Now, how does a blockchain work on the low level? It is literally a chain of blocks of information, and you essentially get a block. You see these boxes here. It contains this. It contains a previous hash. A hash is essentially a single piece of information to which you ended up with an algorithm using cryptography. So I could take, for example.
Sorry for interruption. Sorry for interruption. Are we changing the slides in the presentation because now we see the network?
No, you should be able to see a slide with 4 boxes and a trash can.
No. Now we just see the network with like miners, full nodes, and light clients.
Let me see if I. Give me a second. Sorry.
Sure.
What do I have to change this? Did it change now?
Not really. No, still the network.
Okay, so I'll leave it like that. I think that works better actually.
Okay, yeah, now we can see.
So I will leave it like that, and that's fine, I guess. Is that okay?
Yeah, it works.
Yeah, so I'll have the cursor as well, so you'll be able to see everything. So essentially, we get a block, right, that contains a hash, which is a string of letters and numbers, to which we end up using a cryptographic algorithm. We'll see a couple of them today. and nonce, which is a number used only once, right? So it's like say 1, 2, 3, 4, right? So this is block number 1 or block number 2. A Merkle root, which I will explain what it is, and a timestamp, right? The next block contains the hash of the previous block. Okay, so I take this whole block and I run it through the same algorithm, and it gives me a particular hash. Okay, and this is what makes blockchains essentially immutable. You cannot go back and change one of the blocks without having to change all of the blocks of information. So this is the second important characteristic of blockchains, is that they are immutable, just because every block is connected with the previous one cryptographically. Now, when we have all of the transactions taking place in a particular second, what we do is we connect two transactions, and these are then hashed, and then 01 with 23 are then also connected, and they're also cryptographically hashed together, and that's how we end up with a Merkle root. So at any particular second in, say, the Ethereum network or the Bitcoin network, you have transactions that are taking place in the memory of the miners, and these are combined together, and they end up with one particular root in one particular block. Is that clear to all on how it works? Do you have any questions on this? Because that's
I think the structure is pretty familiar for all of us. The question is, what does mean the block n+1 header with a bin in this diagram?
So what happens is, as everything is taking place here, what they're trying to establish is which one, or you might end up with a competition of two next blocks taking place, and only one of them will survive, and the others are going to go down to the garbage essentially. And this happens because of a competition through the miners and competition to synchronize the network. So to make a decision on this, for most blockchains, what happens is the longer blockchain wins. And I'll explain what that means by going back to the network. So imagine that these half are looking at 3,000 transactions on this part of the world, and the other half of the network are looking at 1,500 transactions in another part of the world. How do you decide which one of these two blocks will go forward, essentially? So you have another algorithm that essentially decides which block is the legitimate one, and which block will go, it will be thrown away at the moment, but the transactions do not get lost. They will be incorporated in the next block. That's why sometimes you have to wait in a transaction. You have to wait in a blockchain for your transaction to go forward. And just to show essentially the competition of how mining happens, right? So imagine 3 nodes here. These are the nodes that are competing for resources and for incentives, and the way they solve this is the Ethereum proof of work algorithm. What they do is they have a number used only once, the previous header of the block that goes here. They have what is called the SHA-3 algorithm, which is a cryptographic algorithm. They take all of this and the transaction, they put a 128-byte mix, and they end up with a number which they compare with a pre-selected target. If it's a match, then that node, in this case, node number 1, is elected from the network to generate the new block. And node 2 and node 3, which are not matches, right, lose the competition. So node 1 is awarded an Ethereum token from that point of view. Up until here, this is what Ethereum and Bitcoin have in common, right, as infrastructure. But Ethereum essentially said the most basic information is this, that if in Bitcoin you're able to do addition and subtraction, well, why not also be able to do multiplication and division. At the moment you have a multiplication and division and addition and subtraction, that's a computer. So essentially the whole network can be treated as a global computer to which we offload computations. And those are the smart contracts. So you see here the Ethereum blockchain essentially, right? And certain pieces of information inside the blocks are essentially smart contracts or smart contract transactions. So the whole network essentially collectively keeps hold of smart contracts. And if you have an address that is valid on the network, so if you have an account on the network holding also specific cryptocurrency with which you can trigger certain actions on the smart contract, then you can instruct the Ethereum's virtual machine, the Ethereum computer, to do a transaction for you or to activate certain things on a smart contract. Does that make sense?
Yeah, I think so.
A little bit. Okay.
Maybe it will be nice to elaborate the idea of global computing one more time.
Yep. So I'll go back to the network, right? So initially I presented this as a network of computers where they keep a record of everything that is taking place as transactions. But instead of just keeping record, I also tell you they're also holding in their memory, well, essentially in their network as well, a set of programs which are executed if you have the right address. Then this is what then makes the network a global computer, in the sense that it is there, it is being run by the peers, and you don't need to have a server, for example, or any other kind of infrastructure to maintain it, right? It is maintained peer-to-peer, and it is an infrastructure that is trustworthy in the sense that it will actually do the same thing every time, and it is also reliable and resilient in the sense that removing nodes from the network will not crash the computer, essentially. So you have what is called essentially the Ethereum virtual machine for Ethereum, and on that you run essentially smart contracts, which are for anyone that has done any coding, they are the equivalent of software classes. So we'll see an example later on, and you'll see how you essentially interact with Ethereum on that level. Just an example again on how the ETH algorithm works. You can find it here, and a bigger zoom in on what a block of information would look like. It might also contain, obviously, a loading of a smart contract. Now, the Ethereum virtual machine is essentially Turing complete, right? Which basically means that we do not know whether a computation will terminate, and we need an external trigger to terminate the computation. And this essentially means that you need a way to have the computer stop executing the program, because you run into the danger that you might have an eternal loop. So you might have the code run forever until it runs out of resources. So to introduce the idea that the system is not abused by someone, or that you avoid costly mistakes, they introduced the concept of gas, and gas essentially pays for computation execution. So at the face of an impossible computation, a computation that has been set up in the wrong manner, the process will run out of gas, literally. And there is a connection between gas on Ethereum and the actual cryptocurrency that it runs on. And by the way, all of this is set up on Ethereum. We can discuss also differences of Ethereum with, say, other blockchains like Tezos or Cardano, which are a little bit more newer, but same kind of principles apply. So what about smart contracts, right? So smart contracts are software that execute on the Ethereum blockchain automatically. You can think of them as classes of code that run on the Ethereum virtual machine. So essentially, every network, every node on the network is running essentially the Ethereum virtual machine and has a copy of the Ethereum blockchain. And from a programmatic perspective, this is a digital protocol intended to facilitate, verify, and enforce the performance of a contract, which basically means that you have credible transactions without intermediaries or third-party guarantees, right? To give it a very simple analogy, right? You don't need a bank. You don't need a third-party institution to tell you whether a transaction is valid or not. The code is a transaction. The contract is a transaction, and that's it. The closer to the physical world equivalent of a smart contract is an automated vending machine, right? You put in €1 and you get a soda, right? And that you have the trust that this will work every time. So what kind of decentralized apps do we have at the moment? We have decentralized finance, where people borrow or lend money between them. You have decentralized autonomous organizations, so essentially organizations that are being run on the blockchain through smart contracts. Examples of these are DAO Stack and Aragon. These are big software stacks with which you can use to run a DAO. You get fungible tokens. For example, a circular economy credit system, right? So fungible tokens are tokens that are interchangeable between them, exactly like fiat currency, right? So a euro is interchangeable with another euro. Non-fungible tokens, which is a strange way of describing unique objects. For example, artwork secured on the blockchain. And this essentially means that the token is not exchangeable with another one and is totally unique. You get examples of supply chain where you get traceability of goods. This is really particularly useful for material passports or traceability of food, for example. So any kind of traceability that you want in a modern supply chain where you want to establish origins of a particular product without in particularly needing to trust the supplier. Escrow accounts and legal contracts, right? So you could set up, for example, accounts where you only get paid if something else happens, if another event happens. Escrow accounts in particular are something that is being used a lot in architecture and construction in large projects. And you get games, obviously, that use a combination of the above, right? So CryptoKitties and CryptoPunks, they all use non-fungible tokens. CryptoPunks are, unique non-fungible tokens, whereas CryptoKitties also contain an evolutionary mechanism with which you can generate new NFTs out of a combination of previous NFTs. Hence the game aspect to it. So examples of decentralized applications in the architectural engineering and construction industry, we have DAOs, obviously, that could be used to design, construct, and operate buildings. You have decentralized design applications, and we'll see an example today. You also get digital twins, like plantoids, right? So you could have a model of a building operating on the blockchain and being changed according to what happens in physical reality and vice versa, right? So you might have physical reality change according to what happens to a digital twin. You have NFTs, of course, supply chain and escrow accounts. I'll stop here if anybody has any questions.
Yeah, and maybe also one question according to these slides. One, we're talking about like Ethereum as a as a main like infrastructure about smart contract. Can we use like a different, and what's the difference between like another for instance like Bitcoin? Can we use like a smart contract in Bitcoin?
Smart contracts on Bitcoin are a bolt-on and they don't work really well. So I would avoid Bitcoin as a platform for smart contracts. The difference between, say, Ethereum, I'm going to stop sharing here and I'm going to open, let me open a couple of browser windows to give you some examples of other blockchains. So I'll show you three examples.
Mm-hmm.
Other than so you should be able to see my browser.
Yes, we can see. We can see
Can
where.
Can you read this?
Yeah, making work better for.
Okay. So this is Cardano. So Cardano is a proof of stake blockchain, and I'll explain what that means compared to a proof of work like Ethereum or Bitcoin. So as I described the two previous blockchains, Ethereum and Bitcoin, you had this kind of algorithm, which is called the proof of work algorithm. So the node that is going to be awarded a token, the node that is incentivized, needs to work, needs to execute a specific mathematical algorithmic process to be awarded a token. And this is how we secure the network. And this is, in terms of electricity, expensive, right? Because all of these are running the same algorithm, and some of that work is being thrown away. They also came up with a cheaper and much more environmentally friendly algorithm, which is used for, say, Cardano or for Ethereum version 2. So Ethereum is moving to a proof of stake algorithm, where what happens is each one of the nodes participating stakes a set amount of cryptocurrency, and if they don't behave, they will get their stakes slapped. So they will lose money essentially. So that's how you incentivize nodes to be to participate with a good level of trustworthiness for the truth. And then every cycle of transactions, one of the nodes is which is being honest, and we know about that by looking at their behavior, is selected to mine the next block and to be awarded some cryptocurrency. So Cardano, which is in the early stages, it doesn't have, they haven't launched the smart contract process yet. They are doing so this month. Uses proof of stake. It is much cheaper to participate compared to Ethereum proof of stake, and it was created with a lot more accessibility in mind. So for example, they're doing a couple of smart things with smart contracts and the way they operate them, non-fungible tokens and so forth. We'll go into detail if you want to. Iota is another one, which is, it's a blockchain run on Internet of Things, so on small devices, right? Your fridge, any kind of home device that you might have with a smaller footprint. And if you take this to the fourth industrial revolution context and the context of a factory, right, any kind of small microprocessor might be able to run the Iota blockchain. And Iota also uses a proof of stake algorithm. And you also have Tezos, which is also a proof of stake and is a lot more peer-to-peer and open source in terms of how it is being run. And it has one of the best platforms for NFTs and for artists, essentially. So I'll stop here. Does anybody have any other questions on this?
Oh, I think now it's much more clear. Yeah. Yep.
Okay. Okay. So I'll move on a little bit to the architecture, engineering, construction industry. Let me put in some coffee, and I'll be back in 1 minute.
Yeah, sure.
Okay. So if you take a look at the architecture, engineering, and construction industry, compared to other industries, you get a landscape which is fragmented, right? So you have a lot of smaller players collaborating between them to be able to design a building or construct a building or operate a building. You get an industry which for the last 20 to 30 years has had an increase of productivity of only 1%, which if you compare it to other industries like the automotive industry or the, I mean, the two classic examples we compare with is the automotive and the airplane manufacturing industry, where they have an increase of productivity of 5 to 10%. And one of the ways they were able to do that is by being vertically integrated, right? So you have all of the smaller players are now incorporated into larger entities. And the other way the architecture, engineering, construction industry is structured is that it is structured in an adversarial kind of point of view. So when you finish with a piece of work, say in the design stage, you know, you pass it on to the next stage, and you pass on also all kinds of liabilities, right? There is no assumption of responsibility for what will happen in the next stage. And in certain cultures, more so if you have ever gotten into a discussion with a construction lawyer, you will see that they see the world. So lawyers see the world a lot differently compared to architects, right? So if you try to collaborate as an architect, your first point always is to try and find a way forward and, you know, create a building and solve that. But if you talk to a lawyer, they will try to see all kinds of let's say problems with processes. So that's the landscape we're facing now. It's also a very wasteful industry, right? So we are producing, forget just about carbon, but if you look at the waste that construction is producing, it is on an obscene level. So how did we get into blockchain through all of this, right? So we started working with this in 2017. Well, actually a little bit earlier. So while I was in China at Xi'an Liverpool University, I became the director of the Innovation Hub, and we were looking into blockchains. And then when I moved back to Europe, there was a competition by the Chinese government for new cities, and one of them was branded as a big data blockchain city in Heilongjiang in Guizhou province. And what we did is we designed a new city where we would incorporate large blockchain data centers at the fabric of the city, and we computed it in such a way where we would use the excess heat generated by the Bitcoin miners to hit the apartments in the city. So from that point of view, it wasn't really smart to the level of using the blockchain for something that has a kind of activity in the city, but on a really direct physical sense, the design of the city was optimized to take into account the energy generation from Bitcoin to be converted into heat for teleheating. And there's an algorithm running behind this that decides where everything goes, right, where you get more concentrations and so on and so forth in this landscape, right? We can debate whether this is good or not, right? But it's essentially automatically generated. And through this, we were able to actually get the third award out of 1,000 entries, which kind of gave us the idea that some of these ideas are worthy of looking into them a little bit better. So we started looking into connecting essentially building information modeling. So all of the tools that we use for describing a building in the modern era with blockchain. And the reason why we did this is because building information modeling essentially is a database that then gets rendered into a building, right? So you see here a school in Scotland as an IFC rendered into Blender. And our initial thinking was that we will replace the database that BIM is running on with a blockchain. So that was the kind of first naive kind of idea. This is almost impossible in the sense that it would be extremely expensive. But as we looked into all of the possibilities of creating decentralized applications, we ran into a couple of other applications, which I'm going to go through at the moment. And we started playing with those on trying to integrate essentially architectural design and BIM with a blockchain. So we kind of conceived the idea that you could have an architecture office which would be run as a decentralized autonomous organization, not as an entity or a set of entities that are formally organized. And through smart contracts on Ethereum, you would be able to design, construct, and operate a building. And our first task, obviously, was to look at the design part and more so at the design optimization prototype. So could we actually use, as researchers, our question was, could we actually use smart contracts to optimize a design and organize the work around architectural design, right? Could we do that? And the answer is yes. If you read this paper here, I'll explain a little bit how this works, right? So this is a diagram of the smart contract that we run, plus all of the other tool set. So you have a decentralized autonomous organization that operates a set of smart contracts, these ones, and they set a problem of design onto the world, right? So they say, here's a design problem, I want you to solve this. And everyone who solves this will be paid. So they set the problem first. There is a smart contract that handles the solution, one that connects with everything else. I'll explain what BIM Manager and IPFS are a little bit later on. But what makes sense at the moment is to describe the way this collaborates and how you can structure through all of this collaboration and competition. So once you have, so this is a problem setting here, right? And this is a problem solution here. And imagine you don't have only one or two architects doing this, but you have 300 or 400 on the internet. So, and some of them might not be even human, right? You might have a machine learning algorithm. You might have an AI solving the problem. And you have two modes, right? So one is a competition mode where all of the design agents they find a solution to the optimization and they publish this optimized value. And at some point, the time runs out and the design agent with the best solution gets paid and everybody else does not get paid. But the collaboration scenario is a little bit different, where the design agent, all of the design agents publish all solutions to all agents, and they each then synchronize with the best solution. Right? So if Nikitin finds the best solution, then he publishes it to all, and then we all restart our design process from that point. And as we go forward, so at some point, system nodes designer 2 has contributed to solving problem. System nodes designer 3 has contributed to design a problem, right? Then we synchronize. Sorry. And then funds are shared between designers 2 and 3. So this is the collaboration side, right? If it's a competition, it's always, the designer who finds the solution, the best solution, is the one getting paid essentially. And we, let me try and put another presentation to show you what this looks like.
May I ask a question now?
Yes, please.
Yeah, does it mean that it's kind of unified database with design solutions? Or
yes, it can do that as well. So you could set it up so that every design solution that gets optimized remains on the blockchain, and then someone can refer to it later on. But in this particular problem, what we were trying to do is solve a structural engineering problem. Let me try and find this. Yes.
One more question is who
Yes.
defines what's best, and how is that defined?
That's where we are cheating. So if you are working with the design optimization problem, there was always a numerical answer to it. If it is a true design problem, with design problems are wicked, so you don't have a clear-cut quantifiable answer. Then it gets a little bit more tricky, and we have a solution for that, which is essentially voting or a discussion, as you would have in an architecture office, where imagine a team or a set of teams who create a set of design solutions, and then you have to go into some kind of discussion to say, well, this is best, this is less best, or which design solution is the best set of compromises for the parameters you're trying to kind of solve. And always in design, you also have the what I'm trying to call, it's not just qualitative, but also those values that are not easy to explain or not easy to express, which are always the magic, if you want, behind design. Sorry, I don't want to get too metaphysical, but you probably understand what I'm trying to say.
Thank you.
So on that level, I wanted to introduce also IPFS, right? So let me walk you through the mechanics of this. Right. So we had this kind of idea. We are using a test blockchain. We deploy the smart contracts on them, and then essentially we publish the files that we want people to work with on what is called the interplanetary file system. So IPFS is a kind of distributed database where you can store files, and you use these ones whenever you have large files you want to share with the world or with the blockchain, and you don't want to store it on the blockchain because it's too expensive. So IPFS actually, I think, is for us architects a much more groundbreaking technology, because it is kind of a you can build onto it kind of peer-to-peer infrastructure like Dropbox or any kind of other cloud or server-based application without having to rely on one particular supplier. And then you have a web interface. So you get a problem owner details that you register, problem optimizer, right? You use your MetaMask, which is a blockchain wallet. We'll see all of this later on in practice. You create a problem, you load it to IPFS through this website. You sign the contract on the blockchain by sending the hash of the file over there. And then you open the problem to people to solve it. And as they do so, they start sending both the numerical data and the file to the website and the smart contract. And once you have a winner, essentially, or time runs out, or the problem owner decides that it's time to close the competition, you can close the whole situation. At the same time, we created a plugin for Grasshopper that you can download from Arc Chain, where essentially you send, this is what it would look like if you were actually solving the problem. You send an optimized value, you send your private key and the address to the smart contract that holds all that. And this one sends it back to the smart contract on the blockchain and automatically registers for you the solution. And if we set it up collaboratively, you get part of the value. If we set it up competitively, you get all of the value assigned to you automatically. So that's the first actual prototype that we built. You can find the whole code onto the Arc chain. Let me try and find it for you. And I'll share on the chat on Zoom.
May I ask also, not really smart question, but I think it's important to highlight. Can you say one more time why it's important to replace existing kind of type of database to blockchain-based infrastructure of sharing file and sourcing file? Yeah.
So I think the main point we're trying to make is that we have gone. Let me explain how the internet was like 20 years ago, right? So 20 years ago, you did not have. The internet was truly decentralized in the sense that you did not have these big conglomerates like Amazon or Google actually dominating the space. They were early stages on, right, creating that, but you had a lot of options in terms of what you wanted to do on the internet in terms of storing files, right? It was a lot easier to run your own infrastructure, right? So running your own server that would be connected to the internet and so on and so forth. You know, fast forward 20 years now, what we get is a case where large parts of the internet are run by Google, are run by Microsoft, Amazon, and essentially a lot of times you don't know where exactly your files are or where exactly your private data even is being run on a cloud. So you are essentially trusting a third party with your data. Now, you might say that's not a problem, but depending on what happens on the world, and that is also connected with money. And I'll give an example of that. I'll give a really good example of that. You might not want to have certain files or certain information about you in such servers, right? Whether that's Google or Amazon or Microsoft or even Apple. I mentioned Apple because their business plan is much more positioned towards cryptography and privacy and not sharing essentially a lot of that information, unless you're a citizen of China, where they actually do. So, you know, if even in that jurisdiction, they would compromise from that point of view. The other thing that I think is important is that it is important that we maintain a peer-to-peer, architecture for the internet, and we kind of resist essentially that kind of idea that everything is being run through large servers. It's actually difficult to do that because a lot of the other competitors to Amazon, Google, and so on and so forth, they also end up in large data centers. So it's, if you look at the physical infrastructure of the internet, where all of those machines are, they are centralized in particular locations, which is not good. But going back to the discussion about IPFS and blockchain, what these things allow is they allow a much more democratic and equal participation onto information for us, right? So they allow a much more horizontal spread of value compared to a vertical spread of value in terms of how you collaborate, in terms of how you store information and how you structure information. There is also, from my kind of perspective, the idea that, if you don't own the tools that you use for your house or for your design, essentially, right? And this goes back to, using as much open source tools as possible, then you are always in danger that Autodesk or any other kind of corporation of such might change the way the game is played. And what these guys listen to is they listen to big companies, right? So if you're an independent architect, if you are one of the small fragments of the architecture, engineering, and construction industry, then you're in bad luck with those kind of deals. Sorry, I might have went a little bit more political than I should, but
no, it's perfect. It's good.
Okay. So let me try. So the code and prototypes is here. And
shall we open the link?
If you want to, yeah, I'm trying to find the guide as well, so it's better if I give you a guide. So this one, the BIM for blockchain installation process, if you have 2 or 3 hours to spare and you want to try it on Windows, you can do so. Because this runs you through the whole thing, including the Grasshopper installation file. But this was in 2019, right? So we have better prototypes now. Let me go back to where I was. Okay. So from that point of view, this is the model again, right? You get on a very basic level, you get the 3 designers working together. You get a design inflection point where something happens, and you suddenly realize that this is a good design solution, and you share that with the rest of your team on a basic level. And we wanted to find a way to do that. So we started generalizing our smart contract architecture onto a way where you could run, we could introduce what we call the decentralized building information modeling, where essentially you have decentralized storage on IPFS, where a BIM model is being run. These decentralized storage, you get peers from all over the world to contribute disk space to it. The user agencies are the architects here, changing the model, and the only thing that you record onto the smart contract on an Ethereum address is the differences. So you don't record the whole model, you only record the history of changes. And that way you are able to essentially be nimble in terms of the infrastructure. At the same time, you run the infrastructure, you run your model onto a peer-to-peer resilient infrastructure, and the people who are providing that are also getting paid by the architects. So essentially, this is more of a theoretical model of how you could create an infrastructure for modern architectural design on a peer-to-peer basis. And at the same time, we started thinking of also other new ideas in terms of business models, right? So we thought of, at this current stage, when you are designing a building, you kind of generate all of the information for it. But every time you design something, you will get into the habit of kind of, creating unique solutions for particular problems, right? Whether that is a facade, or whether that is a kind of structural detail, or it might be also a spatial configuration that is a little bit peculiar. And all of that is unique to that particular building, and then you probably will use it again if you face the same kind of or similar problem in another project. But what you could do is you could actually create a BIM model out of those solutions, publish it on a decentralized storage, lock it essentially on the Ethereum blockchain. And then when another architect uses it and changes it to another BIM model, you get a token is generated, and based on that token, you get paid. And then when a third user also then changes that BIM model too, without asking permission, you also get user B and user A also gets compensated. So we could start creating a more, I would say, we have already the idea of sharing information peer-to-peer on the internet, but this also incentivizes people to do the right thing. And when they change and use your information kind of in a Creative Commons kind of sense, you also get micro payments for that contribution essentially to that file. And this is something that has been already being proposed also for other arts like music or painting, right? So I'm not claiming it's unique essentially on its particulars, but it does change the way we see architecture from an architecture which is always praises the prototype, always praises a unique solution, to creating a case where you could make a living by offering your intellectual property to the world and still remaining positive that you will get paid. So we are trying now to work out the exact mechanisms for that, right? So we were able to actually create an NFT, a non-fungible token for this. We need a couple of more contracts to test this. On another prototype, going back to the question of how do you decide what is good design and what is not good design, right? We created a DAO on DAO Stack. So we created a decentralized autonomous organization where designers propose design solutions. We use the formalism of safe grammars to simplify the process, right? So you're not just selecting a design solution, but you're selecting the best grammar possible for a set of apartment towers in China. And you generate building options out of that safe grammar. These are then run through a design daylight analysis. This is what designer 1 does, but designer 2 and designer 3 are also doing the same thing. You upload everything onto a storage space on MPFS, and then you vote essentially which one is the best, which one is the best to take forward. And on voting, we also set up a way to recognize experience, right? So if you are an experienced designer or experienced researcher, your vote might count a little bit more. But this also still allows young designers with good ideas to also have a say and move forward essentially. So that is a kind of halfway solution to the qualitative problem of how do you select essentially design solutions. Moving then forward, what we're working on now at the moment, and this is where you probably found us from, was the tokenization of buildings and setting up the blockchain as an information layer for circular economy, right? So I'll take you back to what we were discussing about building industry, the architectural, engineering, and construction industry being extremely wasteful. So let's take it from the point of view of recycling buildings or even reusing buildings in different configurations. At the moment, if you want to recycle a building, normally what will happen is you will reuse part of the building that was demolished at the site you're trying to build or close by. It is very difficult to actually find information for reusable component. It's actually very difficult to find information on buildings that might be under demolition or under you know, they've run the length of their life and they are to be taken down. So we thought it would be good if we tried to use the blockchain as a persistent record of what you have designed. And one of my really good colleagues on this project, Vasim Jabi, has created what is called Topologic. Topologic is an app. Let me run this through topologic.app, which essentially is able to represent a building in a kind of non-manifold topology. And you can see some of these representations here. And from that point of view, it's a lot lighter compared to a full BIM model. So Topologic can be run as a kind of BIM light kind of library. It runs on Dynamo, it runs on Grasshopper, and it now runs on Blender as well, even though it's a little bit wobbly on Blender. Vasim is trying to solve this as much as possible now. I'll give you links to GitHub on Blender, but also to the Discord, so you can join on that. And the process here, or what we're doing, is we're taking a building, we analyze it in terms of topology, and just to go to the very basic level, right? You reach a level where you have a beam or a column. These are represented by edges, which are topologically connected to a room, and each of the both the spatial entity and the physical entity are translated onto non-fungible tokens, so unique digital objects on the blockchain. And what happens is that you assemble this then onto one non-fungible token that represents the whole building. So you have a tree of topological representation. We'll see an example here of running Topological on Blender, and a building with an atrium in the middle. And you essentially take all this and you're able to upload it onto a smart contract, and as such tokenize the whole building, which is also made out of other tokens. What does that mean, right? In practice, it means that you have a smart contract which is keeping track of building components you might have created. And when the time comes, you're able to, you have an information layer that tells you, that building contains this amount of concrete. It contains this building component that you can reuse, right? So you can essentially put all of that on the smart contract layer. And that's what we're working on at the moment, actually. So we're working on showcasing an example of that, but also what we want to create, which we haven't yet. I'm gonna stop sharing for now. Is create a kind of search engine for building components, because the moment you put it all on the blockchain, you also need a way to actually retrieve information from it and say, well, if I want to do industrial installation using these particular metal pieces, you know, how do I do it? And you might have essentially kind of like a search engine or a helper as you're designing, and it might tell you, well, in this area you're designing, in this particular closer, in this particular distance from you, and I'll explain why distance is an issue. You have these resources available. So instead of you coming up with a scenario where you're designing with any resources in mind, you are being fed as a designer all of the best possible low carbon solutions that you could use. Either these have to do with reusing building components as being fed by this system, or if you connect essentially supply chain information, again, through blockchain onto the design. And if you connect it again with any kind of incentives or punishment kind of scheme to say, well, if you use this kind of resources, then you get paid more. And you use this kind of resources means that you have a lower carbon footprint. Then suddenly you have a mechanism where you can incentivize good behavior in terms of design. But again, these are all still things we're still working on, right? So we haven't yet created those kind of mechanisms. So I'm going to stop now. Any questions?
Yeah.
So that search engine, just so I understand, this is more than just a search engine for based on materials, but it's also, is that also based on particular like design details or like information as well? Like does somehow that connect also to this idea that you had presented earlier about this like way that design details can be like crowdsourced in a way?
Yeah.
Cool.
So we want to basically create, you know, use the blockchain as a kind of global information layer for architecture, where you could have all of these models running in all of these ideas running in parallel, right? So where you could say, okay, here's my building assembly for a unique facade, and I know this works in certain climate conditions, right? So you publish this, and that is a design information. But you also might have material information that might come from a particular provider of, say, you know, concrete with a low carbon footprint because of its composition, right? And a supplier publishes that information for a particular area, and that makes it much more easy for you to know what kind of suppliers you might have by using automation, essentially.
Can I ask a sort of follow up about the at what sort of level of abstraction would it make sense to store that material information? Would it be as sort of volumes, or would it be kind of precisely geometric? Because I mean, there are different sorts of circular economy kind of scenarios, aren't there? There are ones of like really very direct reuse of things as they really are, for which I guess you would need extremely precise sort of geometric data rather than just volumes or these kinds of things.
Exactly. So this is connected to exactly how you have the component set up. So if you have, because the reusing of building components also requires that you think in a design for assembly kind of way, right? For example, a building made out of cast concrete is very difficult to be recycled in terms of building components, because the way it is structured already kind of creates a monolithic organism. But if you have a building made out of precast concrete with the joints already being able to be disassembled, then you're able to do it. So the question is exactly what you're asking, you know, how do you store that information? So what happens is you have the topology regulating the relationships between building components, and the exact geometry is then being stored on IPFS. So you have IPFS essentially handle all of the expensive storage, and the blockchain handles the topology and all of the relationships. So when you are actually, the way we think it's going to work, I mean, again, as I said, we're building this at the moment, is you're going to say, well, I want four beams that are these kind of sizes. The blockchain is going to tell you, yeah, these are the basic information you want. And then you will retrieve the whole, you know, you will retrieve in your building information model the exact sizes from IPFS with everything, including all of the composition in terms of material and so on and so forth. And if that works, that's fine. If not, then you start another search, essentially. The more direct in terms of, but this is a scenario that we are already looking at designing a new building reusing previous components, which also means that you have at least, say, 50 or 100 buildings in a particular area already on the database, right? So this is already a really positive scenario in terms of people choosing to use this. The more direct circular economy example we would see would be a case where for new builds or even retrofits, suppliers actually provide the information for the materials, and then while you're designing, you immediately get recommendations for the low carbon materials. So that would be the kind of the first, I would say, the most probable scenario to see early on compared to the one I described that requires a lot more involvement from a lot of architects and building developers. Okay, so if you want to try this, we can try the smart contract if you want. Okay. Yes, so you go into MetaMask, right? You install this. It will probably give you a secret passphrase, which you need to always remember.
Yeah.
And then you essentially have various accounts, right? So I have more than one because I'm testing various things, but I'll walk you through the main features. You can also get MetaMask on your mobile phone, right? So you can try that. The main point is that you see how many ETH, which is the main cryptocurrency of Ethereum, you have here, but you also get context in terms of where you are connected, right? So this is how much you have on the Ethereum mainnet, right? So I have 0 on this one, but if I change networks, if I go to Robston, which is a test network, you'll see some contract interactions here. I still have 0. If I go to Kovan, I get 0.98. Obviously, in test networks, there is no value to ETH. You just need it so that you are able to interact with a blockchain. So we'll work now, not with a real network because it's going to be paying us, it's going to be expensive, right? But with a test network. So what I would like you to do is you need to change all to Robston. And we will then search for Robston faucet. Let me put this on. Sorry, I'll open the chat and put all of the URLs here as well. So all you need to do is click on your address, copy to clipboard, and then paste it here and say, send me test ether. So this is your public address. You can share this with everybody with safety. The one thing you must not share is your personal key or your secret seed phrase, because that will allow anyone to essentially use your address. And if you have any real funding on the main network, then they can get it from you. So be very wary about scams where they tell you to give your, if you see any website that asks you to give your personal key or your seed phrase online, that's a scam. No matter how many cryptocurrencies they're offering and tell you they're going to give you back, right? That's a scam. So send me test ether, you click on that. And then,
I have a trouble with on this
Yep.
stage, on this step, I received like a message, you are gray listed. Your gray list period is not extended on IP and address for spamming.
you all have the same IP, don't you?
No.
Yes, you all have the same IP because you're all behind the same network.
Ah, yeah. Okay. Yes, yes.
Let me.
I can do a hotspot for my laptop now.
No. Give me a second. Try this one.
Yeah, request one, right? Shall I press the green button?
Yep.
Then connect with MetaMask. Selected account, right?
Yeah, you need to connect MetaMask.
Okay, connecting. No, it's also.
Let me try another one. Well, I'll tell you what the solution is. So can you paste on the chat your Robston, so your address?
Yes.
You paste it on the chat. Yeah, I'll send you. So I'll show you how to send from one to another.
Yeah.
Okay. So what I'll do is I have one ether. I will send you. So I pasted your address here, and I will send you 0.5. And you also see that there is a gas price associated with it and a gas limit, right? So this is how much I say this is the maximum I want to pay. So next, confirm, and then you get, the value plus how much the gas costs. And then we get pending. It will take some seconds. I already received some more. If I click on this and I go to view on Etherscan, I will open essentially a network navigator where I am looking at transactions. So this is a live transaction at the moment, which we are still waiting for. Success. So if you check your
Yes.
MetaMask, you should have 0.5.
Yes, exactly.
Okay. And this is a way you can track transactions, right? So this is now immutably recorded and you can go back to it and track it. Obviously, this is very low level, right? So it doesn't if this was, for example, sending files, you would not immediately know all of it, but the transactions are all verifiable for every smart contract and every account. So always remember, whatever you do on the blockchain is always public, right? It always can be traced back to your address. So this is why I find it crazy when people say, well, it's anonymous, or it's not, right? So Bitcoin transactions, Ethereum transactions, they're not really hidden. They're always really, really very public.
Mm-hmm.
And then you see now that it tells exactly how many ETH I have, right, and how many I have after. And if I double check, right, it's 5.5 and so on.
Mm-hmm.
So to open a smart contract, you will all need to go to remix.ethereum.org.
Yeah, remix. Yes, it's loading.
It might take a little bit of time to load.
Yeah, I'm in.
Everybody in?
Yes.
Okay. And then I'll give you a contract. It should be public. Can you take a look if you can access this code?
Yes.
Okay.
Yes.
Okay, so that code is essentially the NFT code. And what we'll do today is we'll walk you through what everything does on the code, and how you can create your own contracts really easily on Remix. So first of all, I'll walk you through all of the features of Remix. So this is an online development environment and also a really simple way to interact with the blockchain as you're developing. If you want to go into more details in terms of how you can develop more from the desktop, if you go to Ethereum developers, there are a lot of resources and tutorials, and you can build lots of interesting things, right? So you can learn Ethereum development, you can learn through tutorials, set up a local environment, right? So Remix is not a local environment, it's a remote environment. I would propose, if you want a local environment, to start with Truffle. Truffle is the most expensive, and it has the wider range of examples. And then, sorry, there's a sorry, they're cutting the grass outside my building. I don't know if you can hear that. So after Truffle is Hardhat, but today we're going to see Remix as an online development environment, even though you can get Remix on your desktop as well, should you want it. So Remix uses a lot of languages. Solidity is the main one we're going to be using, because this is the main language where smart contracts are written in the Ethereum blockchain. You get a set of a default workspace here. You can create a new one if you're changing For example, non-extractive architecture. I can create a new workspace that creates a new set of contracts, but I also had this one for my default workspace, essentially. So let me get back to the non-extractive architecture, and you see contracts. This will act as a file explorer. On the next stage, I have a compiler, which essentially translates a smart contract into the bytecode, into the code that the blockchain can run. And it gives us here versions of the Solidity compiler, the language, and the version of the virtual machine that I want this to be compiled for. So you get various versions of the Ethereum virtual machine. These are previous stages of the Ethereum virtual machine. So you might want to run it for a previous version. I'll explain how this plays a role, right? So the language is still under development. So you need to be ultra careful with what your compiler is and how this is connected with the version of the language you're using in your code. So after you compile it, you deploy it on the blockchain, and this is where you also run transactions. Any questions so far?
Can we work in one workspace or not? Can we, I mean, work together in one workspace as in a Google Doc, for instance?
No. So you mean for me to have you write on the one I'm working on? No,
yeah.
That's not. From what I know, that's not possible. That's an interesting question, actually. So let me search for it. Nope. So the only way to do that, to collaborate on that, is through GitHub. So I'll show you a way to do it by using GitHub essentially as a synchronization tool. But there is no way to work here in the same way, live way, where you do it in Google Docs essentially. But that's an interesting question, right? I never had that before. So let me walk you through essentially a cycle of using a contract. So if I start, do you all have the one storage.sol here?
Yes.
And then also what I'll do is I'll press on the plus here so you can see a lot better.
Yeah.
And I'll explain what everything is, right? So everything that starts with these two forward slashes, this is a comment. So the compiler doesn't take this into account, but this is used for instructions to a developer or similar, or to give us a license, right? So this one, it's always good practice to have a license in your code. And this one identifies the license as the GNU public license 3. And try, if you press enter, to say, hello, this is Theo. So try writing a comment.
Okay.
Anything you want, right? Doesn't matter. Let me try and have this here. Okay. So going back, what we have then is a declaration of that this is a Solidity file with the statement pragma Solidity. And you might see this written then as anything above or equal to 0.7 point or below 0.9. And these are essentially Solidity compilers. So this declaration says this code can be run with any compiler equal or above 0.7 and below 0.9. You might also get a compiler statement, and you get the semicolon, right? So you might get a compiler statement that is as such, pragma solidity, upper angle bracket, 0.7, and then semicolon. And this means any compiler above 0.7 can be used to run this. Right? So this is the difference. This provides us with a range, and this basically gives us a lower version that Remix can use. We cannot have both, right? So what I will do now is I will keep this. I will not delete it. It's good practice not to delete things, but to just comment them out. So if I put 2 forward slashes, right, I basically get a comment. And now the compiler has this to work with. If I want to have more of a paragraph for comments, I use this format, which is / asterisks for all sentences, and then close with another /. So all of this is comment as well. Okay, and this basically tells us the title is storage, title of the contract is storage. And when it says @dev, it explains to another developer, so someone reading this, what does the contract do? And it says it stores and retrieves value in a variable. So we will store and retrieve a number in a variable, right? So variable is a value that we can change on the contract. So the real fun begins after this, right? So we declare the contract. The name is storage. We open a bracket. And then you have a universal integer 256. We name it as a number, semicolon. So this cannot take decimals, right? So it will have to be an integer, 1, 2, 3, 4, 5, and so on and so forth. So this is a storage function, right? And the next one, it essentially tells us the function of how we're going to store it, right? And the function is called store. So we declare a function, we give it a name, we tell it what it needs to do, which is give a number to the uint 256. We call it public so that this is accessible from outside the contract. So this can be called outside the contract rather than just inside. The declaration of public or private happens for security purposes. So you might have certain numbers inside the contract that can only be invoked internally. And then we set the number to whatever num you gave it here, right?
Yeah.
So that's setting the number, and we're going to do the same thing in the opposite direction. We're going to return the number with the function retrieve, which doesn't have any kind of arguments. It's public, and what it needs to do is it needs to view and return the uint 256 and returns a number, right? So we have all this, we're ready to compile. So we will go to the next step, clicking here. The compiler we have is 0.4 commit, right? Solidity compile one storage. And it gives us already an error. And it says source file requires different compiler version. Current compiler is 0.8. So let me go at 0.7 immediately. Let's see if that helps. Takes a little bit of time because it's downloading 0.8, 0.7.
Mm-hmm.
And click compile and it works immediately. If you don't get any kind of warnings here, then it worked.
Yes, yes, it works with 7 version.
So writing, compiling, and deploying. So now we're ready to deploy to the blockchain. Pay attention now, because this might be, if you click deploy immediately, you don't deploy it to the blockchain, you're deploying it to a local test environment. So you're deploying it only on your particular machine. What you need to do is you need to go either with a Web3 provider, so a node, a blockchain node in your network, which you don't have. So the next best is injected Web3, which is connecting your MetaMask. And you'll see now that my MetaMask, which is with 923E, is connected here, and it will say Robston 3 network. So change to injected Web3. If your MetaMask is not connected, so it doesn't have this green dot, then click on that to connect it to Remix.
Yeah.
And this allows your Remix instance to connect to Robston through your main account. So once you're ready with that, you click on deploy, and it will trigger a transaction that you will get on your MetaMask. So this is a transaction that essentially packages the contract as data and sends it to the blockchain for deployment. And the moment I say confirm, it says creation of storage pending, right? Let me see what MetaMask is saying. Contract deployment pending. Let me click on it and view on Etherscan. This is why you use a JavaScript local machine as an alternative, because it takes some time to deploy, but it's best if we do it with a real test network for now. It's going to take a little bit of time, but at least you will then have a real simple smart contract you can play with.
Mm-hmm. And in the robster.ethereum-scan.io, you can check all the transaction and see all of the changes.
Yep. So the robston.etherscan.io is a navigator for the Robston test network, and there you can see all of your changes. It's taking a little bit more time than I expected. Sorry about that. Yours might be faster. Or not, again.
Mm.
But I still believe that it's better you use the test network, because it's the closest one to real deployment. So what we'll see also is we'll play with my version, and what I'll do is I'll show you how you can set. So everybody now is deploying their own version. But what we can do is I can give you the address, or you can give me your address or where you're deploying, and we can set numbers in that. Okay, success. So you see now how this is being worked. It says from this account, which is my MetaMask account, to contract, and it says created this one.
Yeah.
So if I go to this contract, I have 0 Ether on the contract, and it gives me a history of transactions. And if I go to my remix, I get 2 buttons as interfaces If I try retrieve, I will get a 0, which is the default value. But if I write here 256 and I go store, I will trigger a transaction.
Yeah, it's strange because I don't have these two buttons like store and.
You need to open this one. So if you have if
yeah.
you have this thing
Yes,
that
yes,
says
yes.
store, yeah.
Yeah. No.
So try like that and then hit store, put a number in, I don't know, 1, 2, 3, or whatever. And then it will trigger a transaction. I didn't complete it, sorry. Confirm. And I did two transactions without waiting. So it takes some time before you retrieve the number.
And can I check my transaction in MetaMask extension?
Yes. So in your MetaMask extension, it says here in the queue, you will get the most current one. But the safest one is to check it on the robson.io Etherscan. It's slow today. So the first one passed, and you see retrieve retrieve is 256, which is the one I set. So this one is confirmed, and we're waiting for the other one.
Yeah.
And you see in the console, I get a confirmation of the transactions, essentially. Okay, so this deployment of the storage contract has taken place in a particular address on Robson, which is different for everybody, right? So I'm going to copy this value to the clipboard. So I'm going to share it here. Okay, so this is my address for this particular contract, and probably is different completely from yours, right? So what we'll do now is I will ask you if you can copy your address, Nikitin, and I will use that to play with your contract. So I'll show you how to interact with an already deployed address.
Okay, I've sent in the chat.
Okay. This looks like a really big number. I'll use Connors.
Okay.
Yeah. So the way it happens is that you essentially, the moment you compile storage, you essentially get an ABI, which is an application binary interface, and a bytecode. So the bytecode are the ones that is the code that is executed by the Ethereum virtual machine. So to be able to interface with these kind of contracts, is you need to have the exact code that is going to be translated into an ABI or a bytecode, and also you how to work with these. But first, let's go through this exercise. And you deploy essentially an interface to your remix to that particular address. So I take Connor's address, and I'm gonna delete mine. So Connor, can I ask you to set a number in your interface and don't tell me what it is?
In the value section.
Yeah, so so what I want you to do, sorry, let me. So use in the store value, set a number, right? And what I'm going to do is I'm going to go deploy the interface to your address and read that from retrieve.
Okay.
Set a number that is not 0. So to be able to read essentially from Connor's contract, I'm just going to copy his address here that says, instead of deploy, to deploy a new one, I have already the storage 1 contract, and I will deploy it to this address here. Connor, as soon as the transaction is finished, just let me know.
Okay. I think it's done.
Okay. So is your number 256?
That was the last one I did. I just put a new one in, so maybe it's not processed yet.
Okay. Let's give it some time. Let me look at, so I can take your address again and then look at your, sorry, am I using the wrong address? Sorry, give it a second. Yeah, I did use the wrong address. Sorry. $687.
Yeah, that's it.
Yep. Okay, good. Yep. So that way now I can change. So Connor had 687. I will put in 55, and I will change his contract. And then you'll see now on his contract address a new transaction. So previously this is his address. From here, this is my address.
Ah, cool.
So did it change on your side? It should now.
I maybe deleted that, tried to close that box and.
Okay, yeah, you clicked on that. So what you need to do is with your storage compiled.
Yeah.
If you go to address and you paste, you need to paste this address that you send me.
Okay.
Paste it here, and then click at address. And that way it will connect your remix instance with the deployed contract.
Okay.
And you can interact with it.
I don't have the ability to the address. Oh wait, no, sorry, I do. Okay. Okay. Yeah.
Okay, so did you get 55?
65.
If you click on retrieve.
Ah. No.
Can you share your screen?
Yeah. I think it's. I think it's not at the right.
Yeah, give me a second. If you, okay, so delete that one. If you press on all of the, if you press on the garbage bin.
Yeah.
Yeah, okay, so you're cleared all of that, okay. You have Robston, that's correct. That's your B4B, that's your address. Yeah.
Okay. I think I did it wrong.
Yeah.
Yeah.
Yeah, 55,
Okay.
yeah, perfect.
Cool.
Yep, fantastic. So that's how you use essentially an address and a bytecode to be able to interface with an already existing instance of a contract. So any questions so far by anybody in terms of process, right? So, you know.
No, I think now it's clear. Just curious how it connected to the building components and how it could be.
Yes. So obviously this is a very simple example, right? So we're just setting a number, right?
Yeah.
I'll walk you through now the code that we have and various other examples. And the way we use it is we don't use Remix to interface. We only use this for verification and for deployment.
Yeah.
Let me try and get my couple of more presentation material. Okay, so let me share. So why doesn't this work? Yeah. Okay. So I will essentially get this code that I've already done as a topo token. Create a new file by clicking on this one.
Can you copy paste that GitHub link again? I don't have it in the chat.
Yeah, we just need to copy paste GitHub. 1 second.
Yeah, so you just need to take this file, copy and paste it here.
Just in the chat of Zoom. I just don't have it in the chat because I joined after.
Ah, you don't have the Zoom, the chat.
No, I'm having Artem just repaste it in the chat.
Let me do it.
Thank you.
Yeah, so this is the code you need to have access to.
Great, thank you.
Thank you.
Yeah, please let me know if I'm going too fast or if you need more info or something is not working. Just let me know. So I'll explain a few things about this because it might get complicated really fast. This is part of what we're working on at the moment. And this is an NFT, so this is a non-fungible token contract, and this just handles the contract side. It doesn't handle the architecture side, which I'm going to show you through Topological essentially. There are, instead of writing the whole contract from scratch, what we're doing is we're cheating and we're using a library. We're using 4 sets of libraries, which are the ones you see here that says GitHub, Open Zeppelin, and then long string, and then it says ERC 721. ERC 721 is the non-fungible token, the first non-fungible token standard for Ethereum. And it essentially, ERC means Ethereum request for comments, and 721 was the original number for that proposal. So when they want to make a proposed improvement to the code in Ethereum, they write a proposal, and this has to go through a vetting process that has to do with how things are developing and selecting the best possible solution. I'll take you to Open Zeppelin. So Open Zeppelin is a company and a group of programmers that basically provide libraries for Ethereum, but also they provide a lot of support and a lot of security audits. So currently they have the best possible libraries for you to use to do basic stuff like owning a contract, pose it, create a non-fungible token, and so on and so forth. So these are really good examples that you can start using in your own contracts. They have a wizard. So if you want to create your own, and you see here, ERC20 is the fungible tokens, 721 is the non-fungible tokens, and ERC 11, 15, 55 is a combination of the two. And it works here by setting up the token, for example, non-extractive. Symbol, then the features you want, so mintable, burnable, pausable, snapshots, and it immediately generates the code for you, right? Just as a way to give you easy access to this. But in any case, it's also easy to actually go to their GitHub and look at the contracts. So they have libraries for access, finance, governance. I won't go into all of them, right? But the main point is what we've done here is we have used the template for NFTs, the template for being able to destroy the NFT, making the contract pausable, which means we can pause functionality if there is a security problem. Counters is for especially helping Ethereum count numbers and not have them revert. This is a problem that Ethereum had until 0.8, where if you have a number, for example, a 256 integer, and you keep on increasing the numbers, say 687, 688, 689, and you reach 999, and you increase it again, instead of stopping, the contract is going to revert to the first number. So from 999, it will go back to 1. So counters is working to help with that. And access control gives access to the contract from other addresses apart from the one that has deployed it. And then what we do is we're setting it up, and we say the contract is called Topo Token, and all of the templates apply to it. And then I set up the poser rules and the minter rule, so who can pose it and who can mint it. Then we use counters for counting the tokens, right? So this can help us increase the numbers without having a security problem. And this constructor here as a function sets up 3 roles, right? So the admin role, poser, and minter. And because I set it up as method center, so the one that sets up the contract is already both admin, poser, and minter. And then it explains what each one of them can do. You can pause the contract. You can unpause the contract. These are only for security purposes, right? So it is good practice to have a pause and unpause function. So if something happens and you need to act, you can pause the contract and prevent anybody else from changing data. Then comes the actual good function of minting the NFT, which essentially works with address, a string memory, token URI. So this is what we are sending to the contract. And this is what comes from Topologic. So we take the whole topology, put it in a string, and we send it to this address. It returns the number of the NFT, and it has a certain requirements which need to be fulfilled, or the minting of the NFT will not happen. And these are that the address that calls the mint NFT has to have a minter role. And then it also checks then where was the counter for the NFTs, right? So if it was like 2, then make it 3. If it was 3, make it 4, and so on and so forth. And also acts and sets the token URI. So I'll go ahead and go here and try to compile it. It gives me some warnings, but nothing in red. So it means that it's working. And then what I'll do is I will deploy a new one. I can pay a little bit more to speed up deployment. It worked. Contract deployment. Let me take a look at it. And let me change my sharing to desktop so that you see the whole thing. Um,
What is IPFC?
I will, if you go to ipfs.io, what I want you to do is go there and then install the desktop. So get
Yeah.
IPFS desktop for your operating system, whether that is Mac or Windows. So either one of these two. I ran it through the command line, so I'll have, it's the same thing. I'll be able to see it through web interface.
Okay, I'm
So,
installing.
sorry, go on.
I'm installing IPFS.
Yep.
Yeah, it works.
Yep. So as soon as everybody's ready, we can I can show you essentially how to mint your own building, more or less. So let's see what I have as an example. Cell phone tower. Uh,
But what is IPFS? It's just oh yeah.
So I have really simple drawings of a house here. I'll just use this one. So once you are ready and you have IPFS running, click on import or drag and drop a file and just select any file. It doesn't have to be a drawing, right? We'll do it with I'll do it with a particular blend file now. So the moment I upload this prototype structures, click on it, it can be previewed, right? Because it's a blend file. But if I click on, sorry, strangely, page went unresponsive, sorry about that. So I get the file, and then the main point is what I want is the CID or the link, right? So if I share this with you, you should be able to access that file. So this is a hash. This is what a hash looks like of that file, right? And all you need to understand in terms of IPFS is instead of, it works exactly like a browser, but instead of saying go to this address, so instead of pointing to a particular place, it points to a particular content. So content is unique in IPFS. Now, what I can do is I can take that hash and put it in the NFT contract, and immediately I've minted a single file that points to this particular design file, right? So I will copy that, copy CID, and go here. I'll do a couple of tests first and explain what all of these means, right? So this is how, with a very simple code here, because of the libraries, I get all of this complexity. So I'm just checking. Yes, I'm on Robston. This is my address. Correct. So what I want to do is I want to potentially approve a transaction. No, I want to create a token using this particular hash from IPFS. And I will give it my address. So I will own that. So transact, it asks me for a transaction and I confirm it. I find the, okay, transaction has passed. I see the green token URI, and I ask it, tell me the token URI for token number 1. And I call it, and it gives me the hash of the file. So I have confirmation this file is number 1, right, and is unique. So what we'll do now is we'll create a new file, and I'll give it to Connor. Nope. Kind of trying to create a courtyard. Okay. Okay, so save this one. Test. Copy CID. So paste it here, and then I'll go back and find the address. Oh, missed that one. That must be Connor's address.
Yeah.
Yeah. Can you confirm your last digits are 7B4B?
Yes, that's me.
Yeah. Okay. So I'm pasting his address here. The token URI is that file, and I transact. So essentially what I did is I created a new file, and then I immediately from its creation on the blockchain, I passed ownership to Connor. So the contract now is going to have two NFTs. One is the original file I had on my name, and then it's going to have a second file with Connor's address. And if I had, for example, to pass ownership of my file to him, I just need to take the token and just send it to him. Let's see if that works. So if I put in call token number 2, I get the hash for the second file. And if I ask owner of token number 2, I get Connor's address. So Connor, congratulations, you own a design at the moment.
Thank you.
It's not really that fantastic, but at least it's a start.
Cool.
So, I mean, on a very simple basis, this is how it works manually, right? The way we automate interaction between Blender and or Dynamo and the blockchain is that we use a library called web3.python and a Python environment. So essentially from Blender, you can immediately talk to the blockchain and say, well, take this file, hash it, upload it, and you're done. So you can interact directly with it. I won't go through setting this up along with Topological because it's going to take us another 2 hours. But I can send you the latest file for Blender Topological on Windows. We're still working on the Mac version. And I can send you also the videos on how to do the Web3 setup. So you can play with those. But the main idea is, again, you can essentially hash on NAPFS any file you want. And then through the blockchain with a very simple contract, you can keep track of those files. Once that is up there, you can essentially then track any kind of information, at least for NFTs. Does that make sense?
Yeah, it does.
Yeah.
It does. I really appreciate this workshop, and also, I mean, a lot of times our discussions here end at the point of needing to, you know, call for new paradigms of management of materials or whatnot, and it's really nice to go actually a bit deeper and more practical of how that might look. So from my end, it's much appreciated. Thank you very much.
Absolutely, I'm happy you kind of find value to this. It's still early stages, but at least we are providing alternatives to what, you know, current management of the IAC industry works with.
Yeah.
We will probably, I mean, if you keep track of ArcChain or my account, I'll give you my account and Vasim's account on Twitter, because we kind of, when we have new stuff, we publish that. So that's me, and then Vasim. And let me find also the videos. I'll do it now, so you have them now. That's from the research workshop on blockchain in construction that happened in April. And we had a really nice, it was three or 4 hours of going through this.
You mentioned also a Discord link of.
Yes, absolutely. So Topologic.
Sorry, can I ask you a question?
Of course.
Since you were using Blender files to connect, like to put in the contract, is it possible also to do it with Grasshopper files?
It's a little bit more.
Yeah, and in this sense, if you're giving like making a contract on a Grasshopper files, that means that you're owning like rules, not a proper design. Is it correct? Because the Grasshopper file is not a proper design, but it's like rules how to design that could be also changed. So that means that if you're making a contract on a Grasshopper file, you're like making a contract on rules.
Essentially, yes, you're making a contract. I mean, a Grasshopper file is a recipe, right? It says follow these steps, and then you will get a design, right?
Okay. Yeah.
So you're creating an NFT on that recipe, yes.
Okay.
The way we work with Topologic as well is on Blender is also with so Topologic runs on Grasshopper, Dynamo, and Blender, and it runs on Sverchok on Blender actually. Which probably Nikitin will probably understand, right? Sverchok means grasshopper in Russian, so they're making a kind of play on that. So essentially, every time you do that, you have to have a blend file as a solid kind of baked design. You can have a recipe as well. Yes.
Okay. Thanks.
So that's absolutely right. Put in the Discord for Topologic, and this is where you'll probably find us. We don't have one for ArcChain because it's just me, Vasim, and Davide. Sorry, I'm trying to get the addresses for the YouTube video, which was
Sorry, yeah, one more question.
As
Like-
many as you want, no
Yeah.
worries. As I'm searching, I probably have, yeah, I'm looking on my email. Yeah, please.
Okay.
How many? What do you need?
No, like, yeah, I was thinking about this, the recipe thing about Grasshopper. So what are the implications of making a contract on like a vague model and also a recipe? So what does it mean actually? Like, because the recipe could be changed. So how to have track of the variations and
All right. So each particular recipe at this particular point, as it is with parameters, will have a single hash.
Okay.
So a particular recipe with certain parameters saying 2, 5, and 8
Okay.
will have, or 8, 9, and 7, right, will have a particular hash. If you change that, then the hash changes. So you might want to say where there is a kind of tension between guaranteeing a certain outcome from the recipe, or whether you're interested in the recipe itself or its output, right? I mean, personally, I would be interested in how this recipe is set up rather than what it's outputting every time. But yeah, I understand it's an interesting interesting discussion. So
Yeah.
let me.
Yeah, thank you. Yeah, just.
I don't have a definite answer.
Yeah.
It's more of a philosophical discussion of what it would
Yeah.
mean essentially to, because there is an interesting tension here, right, between making unique objects and also objects that are copies of others, and from that point of view, it depends on, I would say, the purpose of why you want to do it, right?
Yeah.
If it's just because I want to, so to give you an example of people saying, well, can you take a recipe like or an artwork that someone else has created and make an NFT out of it, right? Would that have any value? And probably not, because you don't want the value lies to the originality of the creator, essentially, right? So so there is a tension there between, you know, copying in the bad sense,
Yeah.
or the in the unoriginal sense, and copying in sense of me contributing value back to the discussion, right?
Yeah. Yeah. Yeah.
And any kind of, from my point of view, any kind of collaboration will require that I take value from you and then you take value from me. I mean, this is part of the agenda anyway.
Yeah.
I pasted the watch list on YouTube for the research conference. That has all of the workshops with smart contracts in the end and tokenization, but it also has all of the research presentations. So you can see what other people are also doing with this on a theoretical level or even on a practical level in the ag industry. Yeah, that's it for me. I hope that kind of generated a lot of ideas in you. If you have any more questions, I'm happy to, you know.
Yeah, I
either
think
have a
like
discussion.
there's like a lot of information and a lot of things to do and go deep, and thank you for your time. And I really hope that it's just a starting point in our conversation. It's just like point one, and we will continue with discussion and in a different format, because I'm doing a research here in the residency, and in the end in July it will be final presentation, and I hope to keep connection with you, and maybe as a consultant or as a part of our review in the end of July. Yeah. Yep. Appreciate
Absolutely.
our discussions.
As I said, right, I'm very happy to collaborate and you know, contribute to this and help you in any kind of way. Just, you know, you have my email, so I'll be happy to be part of any conversation or help you with any part of the projects you're working on. For us, it's really important, you know, I really want to do these workshops because it helps us push our ideas forward and also test them, right? It's really good for, I mean, I never had that question you had about, is it possible to collaborate on a smart contract, which kind of opened a couple of ideas on that. So thank you for that. Thank you for the comments and the challenges. And I look forward to seeing you again at some point.
Yeah, definitely. Thank you.
Perfect.
Yeah,
Thank you
a
guys.
lot. Thank you a lot. Super interesting.
Enjoy. Bye-bye.
Bye. Bye-bye.